Okay, well, so we have to remember to find the circumference. Oops, something's wrong here. What happened? It's being weird, right? That is odd. Okay, so I shouldn't be on yours. Let's get out of here. Is yours good? I just scribbled. Okay. I was just in the wrong tab. Okay, so I think we're gonna skip a bunch of these. Go right to where we start the formula. Okay, so go to the next page. That whole couple of pages were supposed to be like do now exploration, but we're just gonna skip those and get right into the lesson. Okay. So I just want to recap real quick. To find the circumference of a circle, who remembers the formula? How do I find the circumference of the circle, like the perimeter of a circle? Anybody remember? Stella? You got it. So if we're finding the circumference of a circle, it's pi times the diameter. And really what that means when we're finding the circumference of the circle, it's almost like saying the perimeter of the circle. But the way we find the perimeter of any polygon is we add all the sides. The problem with a circle is that it doesn't have any sides. It's one big round, right, curve. So we can't add all the sides to find the perimeter. So when we're saying we're finding the circumference of the circle, what we're doing is we're envisioning if I trace that circle with a string, and now I were to take that string and stretch it out and measure how long it was with a ruler, that tells me how long the circle is, right? That is the circumference. And there's two formulas for circumference. There's C equals pi times the diameter, or we can say the circumference of a circle is 2 times the pi times r, 2 pi r. Because is it 2 times the radius, the diameter, right? So we could either do pi times the diameter or 2 times the radius times pi. But now what I want to do is I don't want to find I don't want to find the whole length of a circle. They're saying find the length of a 30-degree arc of a circle with a radius of 12 centimeters. So let's get a diagram going here. So let's say I have an arc and I'll call it AB. And this arc AB is 30 degrees. And they're saying the radius of this circle is 12. Because I know the radius is 12, would I have enough information to find the whole circumference of the circle? Since I know that the radius is 12. Yeah, I would have enough information to find the whole circumference. Why do I have enough information to find the whole circumference? Because all we need to find the circumference is 2 times the radius times pi, right? So as long as I know the radius, I can find the circumference. But if I were to find the circumference, wouldn't it tell me how long the whole entire circle is if I stretched it out? That's not what this is asking. They're saying find the length of just AB, just the arc, that 30-degree arc. Now, is the length of arc AB 30 since it's 30 degrees? No, that's a degree measurement. A degree measurement is very different than a length. They're saying if I were to stretch arc AB out and I were to measure it, how long would it be? Well, do we agree that AB is going to be a fractional part of the whole length of the full circle? So the way we're going to do that, to find the length of just an arc, new formula for us. Little star. We're going to say length of an arc. Oops, what did I do? I'll just call it arc length. Arc length is going to be, we're going to figure out what fractional part of the circle that arc is. And the way we figure out what fractional part of the circle the arc is, what we're going to do is we're going to say the arc degree over 360. I'm going to move this down so I have more space. So it's going to be the arc degree over 360 times the circumference, which is 2 pi r. And this is a new formula for us to memorize that we've never seen before. So now let's go and find it. So they're saying find the length of a 30-degree arc of a circle with a radius of 12. I'm going to plug right into this formula. So I'm going to say the arc length is going to be the arc degree. Well, how many degrees was arc AB that we made? Wasn't it 30? So it's going to be 30 out of 360 times 2 pi times 12. And that's me plugging into the formula. Now I'm going to simplify. And for 30 over 360, I'm going to cancel out those zeros, divide by 10. But then can I still simplify 3 over 36? Isn't 3 over 36 1 over 12? Up here. So we're going to say 1 over 12 times 2 times 12 is 24. So that's going to be 24 pi. Now, when you multiply fractions, remember, you can cross simplify. So I'm going to say 12 goes into 24 2 times. So our arc length will equal 2 pi. A little bit different, but you'll get the hang of it the more we do. Oh, guys, and remember how for some of us, we're not able to press the typewriter key and it doesn't come up? Well, Jay had it figured out all along. If you just press refresh at the top, where is it up here? If you just press refresh at the top, then it works. Jay didn't care to share that with us, though. He said it was common sense. All right, where's my pi symbol? Do you guys see the pi symbol anywhere?
You just it's in the top right.
Oh, there it is. Thank you. Okay, there it goes. Okay, so find the length of a 40-degree arc if the circle has a radius of 12. We don't need to draw the circle every time. Now it says find the length of an arc, so I know I'm going to use the arc length formula. So we're going to say, let's make this a little bit thinner. So I'm going to say the arc length formula, arc length equals the arc degree over 360 times 2 pi r. That's our formula. Now we're going to plug in with what we have. It says find the length of a 40-degree arc. So where am I going to put that 40? For what part of this equation? Well, isn't that 40 the arc degree? So I'm going to sub in that 40 for the arc degree. So it's going to be 40 over 360 times 2 times pi times my radius, which is 12. And now we have to simplify. So for the 40 over 360, I could cancel out those zeros. And then I can take 4 over 36, and I can simplify that. I could divide by 4, and I'll get 1 over 9 times 24 pi. Is everybody okay with how I multiplied, or are you confused with how I got any of the numbers, either 1/9 or 24 pi? Because I can explain how I got that. We're all okay? So I divided by 10 first, 40 over 360. So that brought me to 4 over 36. And then I divided top and bottom by 4. So 4 divided by 4 is 1. 36 divided by 4 is 9. So now 9 doesn't go into 24. But there is a number that goes into 9 and 24. So because there is a number that goes into 9 and 24, I am going to continue to simplify. I'm going to divide by 3. So 9 divided by 3 is 3. 24 divided by 3 is 8. So my arc length will equal 8 over 3 pi. And I would leave it just like that. I would not change it to a decimal. I would not change it to a mixed number. I would leave it just like that. And now when you come to make the pi, you have to get out of the denominator. If you put the pi in the denominator, you would see that you got it wrong. Okay, so now I'm shaking things up a little bit. I'm making us manipulate the formula. So it says find the diameter of a circle that has a 60-degree arc and that is 60 pi units long. So now I'm asking for the diameter. So I'm going to go into my formula because it does say it has an arc that is 16 pi units long. I'm still going to use the arc length formula. So we're going to say arc length is equal to the arc degree over 360. And because it tells me find the diameter, it says find the diameter. Instead of 2 pi r, do you know which one I'm going to use this time? Pi times the diameter. Because it's saying find the diameter, I'm not going to use the one that talks the circumference that uses radius. I rather use the circumference that uses diameter. So it's a direct find. Now this is where it gets a little bit tricky. So it says find the diameter of a circle that has a 60-degree arc. Well, because it's saying it has a 60-degree arc, do we all agree that's still the arc degree? The arc degree is 60 degrees. Yes, we agree with that. So I'm going to plug in the 60 there. So we're going to have 60 over 360 times pi times d. But now they're not telling me the diameter or the radius. They're saying the arc has a length of 16 pi. So now instead of arc length, here, instead of arc length, they're saying 16 pi. So now I'm going to put that 16 pi for the arc length. And now I need to solve. So I need to solve for d. In order for me to solve for d, I have to get pi all by itself. So to start off here, I'm going to simplify the 60 over 360. The zeros cancel. So now I'm going to have 1 over 6 times pi times d equals 16 pi. My goal is to get to get d all by itself. So I have to get rid of the 1/6 and I have to get rid of the pi. It does not matter which one you get rid of first since they're all being multiplied. So you tell me, which number would you prefer to get rid of first? The 1/6 or the pi? The pi? Sure. Do we all agree the pi is being multiplied? So to undo multiplication, what should we do? Divide. So now the pi's cancel. So now I'm going to bring it up here, and we're going to have 16 is equal to 1/6 times the diameter. Now I could divide by 1/6, or what's the same as dividing by 1/6? Multiplying by 6, exactly. So I'm going to multiply by 6 on both sides, so those cancel. So now on the left side, I'm going to have 16 times 6, which is 96. So we're going to have 96 is equal to the diameter. Okay, I want you guys to try number 4 by yourself. Okay, so what should you have done? Find the diameter of a circle that has a 150-degree arc that is 10 pi long. So you're going to use the arc length formula once again. So arc length equals the arc degree over 360 times pi times the diameter. So the 150 is going in for the arc degree. We're solving for the diameter, and the arc length is 10 pi. How many people plugged into the formula correct? Okay, great. So I'm going to go ahead. I'm going to simplify 15 over 36. So I'm going to divide by 10. Then I have 15 over 36. 15 doesn't go into 36. But what I can do is simplify this further and divide top and bottom by 3. And when I divide top and bottom by 3, I get 5 over 12 times pi times the diameter equals 10 pi. So I could divide both sides by pi, cancel out the pi's. So now I'm going to have 10 is equal to 5 over 12 times the diameter. So we said we could divide by 5 over 12, but dividing by 5 over 12 is the same as multiplying by the reciprocal. So I'm going to multiply by 12 over 5 on both sides. So this cancels. And then on this side, 5 goes into 10 twice. So we're left with 12 times 2 is 24. Okay, so number 5, it says find the length of a 120-degree arc with a circle that has a radius of 15 centimeters. So I want you guys to try to do this problem all by yourself and see how you do with it. It's all about reading it, understanding the information that they're giving you, and knowing where to plug into the formula. So try number 5 by yourself. Actually, try 5 and 6 by yourself and type in your answer. If you get it wrong, raise your hand and then I'll come and look it over with you. All right, how many people finished number 5? Finished? What'd you all get? 10 pi? Anybody want to see me do it? Don't be shy. We're all good? Yes, do it. Okay. So find the length of a 120-degree arc of a circle with a radius of 15 centimeters. So they're saying find the arc length. So we're going back to the arc length formula. And it says it's a 120-degree arc, so we're 120 over 360. And now they're saying there has a radius of 15 centimeters. So we're going to do 2 times pi times r. So we're finding the arc length. So we're going to leave that. 120 over 360 times 2 times pi times 15. So I didn't use pi d this time because they said the radius is 15. So I used the 2 pi r. The zeros cancel. Then I can divide by 12, top and bottom. So I'm going to get 1 over 3 times 30 pi. 3 goes into 30 10 times. So our arc length equals 10 pi. Okay, you guys try number 6 on your own if you haven't already done so. So this time, be careful. They're saying find the diameter of a circle that has a 240-degree arc, and that is 10 pi long.
E equals. Okay.
And the pi's canceled, so that's what we do. Because we solve to get d all by itself on one side. Sure. Okay, so how you should have plugged in here, they're telling you the arc length is 10 pi. So it should have been 10 pi is equal to 240 is our degrees over 360s. And then it says find the diameter. So instead of pi 2 pi r, we're going to do pi d. And we're going to solve for the diameter. I'm going to cancel out these zeros, and we're going to have 10 pi is equal to, now 24 over 36, we can divide top and bottom by 12, and we're going to get 2/3 times pi times d. We're going to divide by pi to cancel out those pi's. And then we're going to have 10 is equal to 2/3 times d. Again, we're solving for d. So now I'm going to multiply by the reciprocal. So we're going to multiply by 3 over 2, multiply by 3 over 2. These cancel. 2 goes into 10 5 times. So the diameter is equal to 15. All right, next page. This is all along the same stuff, so skip 7. All right. Now we're going to put things together. We're going to put shapes together. So it says find the perimeter of each solid figure. The solid figures below are made up of semicircles, rectangles, and equilateral triangles. All right, so now if we want to find the perimeter, do we all agree we have to add up all the lengths of the outside? That's what perimeter is. So now the middle shape is a rectangle. So since it's a rectangle, if the top is 10, do we all agree the bottom is 10? So now I need to find the length of this arc. Well, they said all these shapes are either rectangles, equilateral triangles, or semicircles. So do we agree this arc must be a semicircle? And we now have to remember, what is a semicircle? A semicircle is what? Half of a circle. So if we're talking about half of a circle, do we all agree that's a 180-degree arc? 180-degree arc. So now what I want to do is I want to find the arc length of a 180-degree arc. So now we're finding the arc length. So this is 180 over 360 times pi. Do you guys see how this is drawn here? So doesn't it show that the radius is 3? So if the radius is 3, what's the whole diameter? 6. So I'm going to say pi times 6. So now the arc length is going to equal 1/2 times 6 pi. And now I can cross simplify. I can say 2 goes into 6 3 times. So this arc length equals 3 pi. So if this semicircle is 3 pi, do we agree that this semicircle is also 3 pi? Anybody confused with how I got this so far? So now the perimeter is all of the outside. So it's 10 plus 10 plus 3 pi plus 3 pi. And now we're only going to add the like terms. So the perimeter is going to be 20 plus 6 pi. All right, next page. I want you guys to try number 9. Okay, so what should you have done? Remember, I told you all shapes are rectangles, equilateral triangles, and semicircles. So do we agree this has to be an equilateral triangle? So this is 6, and this is 6. Why was it important for me to know that this segment right here was 6, even though that's not part of the perimeter? Because that's the diameter. Perfect. Now, because it says in the first part of in the directions, I said all shapes are either equilateral triangles, rectangles, or semicircles. So now we need to find the length of this arc. And we know it's a semicircle, so it's 180 degrees. So we're going to say arc length is equal to 180 over 360 times pi d. So we're 1/2 times pi times 6 equals 1/2 times 6 times pi 2 goes into 6 3 times. So once again, our arc length, is 3 pi, not once again, but 3 pi. So now this is 3 pi. So our perimeter is going to be 6 plus 3 pi. How come I didn't add a third 6? How come I only said 6 plus 3 pi? Why didn't I add a third 6 there? Stella? Good. Remember, perimeter is just the outside. That diameter is not part of the outside. It's inside. So our perimeter is 12 plus 3 pi. Did anybody get that right? All right, let's do number 10. Then we'll move on to the next page. So for the perimeter of this is a little bit different. So I'm going to highlight what we're trying to find. So we need to find this semicircle. We need to find this semicircle. And then we know these two segments are part of the perimeter. Do we agree? Okay, so I'm going to find the big semicircle first. So we're going to say the arc length for the big semicircle is the arc degree over 360 times pi d. But now I have to figure out the diameter for the big one. Do we agree what I'm boxing off in pink right here would be the whole diameter? So there's 8 in the middle, then 2 on the left and 2 on the right. Do we agree that's 12? The whole diameter of the big arc? So we're going to say 180 over 360 times 12 pi. So we have a half times 12 pi. 2 goes into 12 6 times. So our big semicircle arc length is going to be 6 pi. Now let's find the small semicircle. Now for the small semicircle, we're going to use the same formula. Arc length equals arc degree times pi times d. The arc degree, once again, is 180 since it's a semicircle. But what's the diameter of the small semicircle this time? It's not 12. Anybody know? What's the diameter of the small semicircle? This is the small semicircle. 8, good. So then we're going to say 8 pi. So we have a half times 8 pi. And so our arc length will be 4 pi. So now our perimeter, finally there, a lot of prep work here. Our perimeter is going to be 2 plus 2 plus 6 pi plus 4 pi. So our perimeter is going to be 4 plus 10 pi. Okay, let's go to page 5. You're going to skip number 12. All the way at the bottom here, after problem number 3, we're going to write a new formula down. So let's put a star. We're going to say area of a sector, and then in parentheses, or sorry, area of a sector, I'm going to put underneath a sector is a part of a circle from sorry, a sector is an area of a circle within a central angle. Okay, so the length of an arc ends up being a fractional part of the circumference. Well, guess what? The area of a sector ends up being a fractional part of the area. So I'll let you copy this down and then I'm going to tell you a couple of formulas. Okay, so we're going to say area of a circle, area of a circle. If you guys remember, that's pi times r squared. That's the formula for area of a circle. And now area of a sector is going to be the arc degree over 360 times pi r squared. Okay, so how do we do this? Find the area of a sector of a circle with a 30-degree arc and a radius of 12. So we're going to use the area of the sector formula. And that's the arc degree over 360 times pi r squared. So they're saying it's a 30-degree arc, so we're 30 over 360 times pi times 12 squared. So we have 1/12, 30 over 360 simplifies to 1/12 times 144 pi. We cross simplify, 12 goes into 144 12 times. So the area of the sector is going to be 12 pi units squared. Okay, let's go to number 6. Find the area of the sector. Do we agree that shaded region is the sector? And do we agree, since this central angle is 90, that this arc is also 90? Remember, the central angle and the arc have to be the same degrees. So we're going to say the area of the sector equals the arc degree over 360 times pi r squared. So now we're 90 over 360 times pi times 2 squared. So we have 1/4 times 4 pi. The 4's cancel, so the area of the sector is just pi units squared. Okay, so this is where we stop. You've done everything. You do have homework. The homework is already posted on Google Classroom.